Okay, we're in section 8, and just to briefly go through the Sage code, it's certainly hoping you've been following along. We've been talking about going to the Sage website, using the interactive CoCalc version, low bar, but you should learn how to do that, right? And at some point you say, gee, I wonder, could I install this on my computer? Now, if you're using a Chromebook, I don't think you're going to be able to install SageBook on a Chromebook unless you kind of rework the system to allow applications to be installed. But if you're running other computers, like for example, Windows or Mac OS 10 or Linux or Unix, you'll be able to install Sage. All right. Now it's installed on my computer, and I'm just gonna type the code in, and it relates to this section of the notes. And we're hoping you studied this section of notes before you're doing the Sage stuff. All right. So reset, X is a variable. And again, you're probably sick and tired of hearing me say this, but it's a really good principle in computer science to define your variables before you use them. And I'm going to type this in. I'm going to copy paste it though. Yes, I've already typed it. You're more than welcome to also copy paste. What is that? That's a rational function. All right, that's a rational function. And next thing I'm going to do is just copy paste this. And I want to point out what it's doing. I've defined a function. It's a rational function. Now I want to plot the function. And I'll put the plot down for you. I'm seeing it now. I'm seeing the plot of that. Now, I got to be honest with you, for a lot of students, that would be a really tough plot to do by hand, but you should be able to get a rough idea what that plot is. I'm not going to say it's going to be as accurate as this one over here, but this looks pretty good. For example, I can look at this. It looks like it's asymptotic with the line y equals 3. Looks like there's a relative maximum here and relative minimums over here. The range of it, I'm going to say looks like it goes up to about 3. Minimal, I'm going to say maybe it looks like it's about, I don't know, maybe 0.4 at the bottom. All right. We'll talk about that in more detail later. Let's go back to the code. And what I want to do is I'm going to define now another function. This has a lot to do with what we're studying. That's why we put it down here for you. And let's see what I did. I see that. If you want to type y of x down to see what it looks like, it might be confusing. It looks like that there. All right, so we typed in. Now, what do they do over here? They want to evaluate y at a number minus, well, what is that? That's 10,000, right? Now, I want to point out, if you put this in, whoops, sorry about that. 10,000, right? If you put this in, it's going to look weird to you. Look at that. I don't want that. What do I want? I want a decimal number. So I'm going to force it to do the decimal. And this is so true with modern calculators. You have to force it to do a decimal. And what do I get? I get that number over there. Now, what I'm going to do is I'm going to put another 0 in, and you may wonder what we're doing. We're going towards minus infinity. Slowly but surely, we're going to get there. What's the next number? Well, I'm noticing a pattern over here. I put another 0 in. And you could play this game all day long, by the way. You're never going to get to minus infinity, by the way, but you could get closer and closer and closer. We're still pretty far from it. I hope you realize minus infinity, you really can't get close to it. It's that far out. And, bottom line is, I'm going to say it looks like it's going towards minus 0.5. Now, in class we mentioned the word limit, and I'll put this down for you. And I want to know the limit of y of x as x goes towards infinity. Now, this looks strange. It's minus. It's actually OO. Now, that's supposed to look like minus infinity. That's a problem. A lot of people look at that. That doesn't look like minus infinity at all. It's supposed to look like minus infinity. All right? And what does it say? Minus 1/2. Well, you know what? Sages can do limits, and that's nice to know. It can do a limit. Let me clear. And what I want to do is I want to go back through the notes, and I'm going to just look back over it, and I'm going to look for some Sage code over here. And I've seen it right over here. This has something to do with the problem that precedes it, like it has something to do with this problem right over here. Now, someone says, that looks like a familiar problem. It sure does. We did that before, all right? So what I want to do is I want to reset. And, if someone says, oh, you already typed it in, you're going to learn by typing it in again. X is a variable. Typing the code in. I'm a little tired again, so I'm going to copy paste. Hoping you remember we just did this problem, right? I'm going to plot it. That's a little different than last time, right? We didn't put x min, x max down. I got a little picture over there. I'm going to leave that picture on the screen. I'm going to come back over here. And let me just take a look at that. And now I'm going to do something. Someone says, what is this thing asking for? It wants to find the local minimum value of the function between 0 and 2. Before I do that, though, I want to look at it. This is 0. This is 2. The local minimum's over here somewhere. Now, remember, when looking at this thing over here, you have a scale down here. And someone says, I wonder what that number is. I'm going to say, my roughness here, I'm going to say it looks like the minimum value is 0.4 and it occurs at approximately 1. Let's take a look, see what this returns to me, see if I can understand it. And what does it say? Well, I said 0.4. It's actually 0.397. I'm sorry, 0.3297. I was off, but not that far off. And what I said the X value was, looking at my picture, I said it was about 1, but it's not 1, it's 0.96. You would have to know how to read that. And it looks strange to me. It does. Why is it? It's giving me the minimum, and then it tells me where it occurred. And this is going to be the Y. This is going to be the X. All right, let's try another one. Let's try between -2 and 0. Again, I'm looking at the picture. I'm expecting something very similar. And what am I seeing? Well, I'm still seeing the same. It's symmetric, but now the X value is about -1. It's certainly, this is much more accurate. You see, it can do it. It really can do it. Let's do the limit as X goes towards infinity. Before I do that, I want to look at the picture. And what am I noticing is it looks like as you go towards infinity or minus infinity, it's asymptotic with the line 3. So I'm going to say this should be about 3. Lo and behold, it is 3. All right. So when you're doing homework, I can't say this enough times, you're doing things, right? Maybe with the use of technology. Let me just read this. It says graph it and indicate what you've learned so far about graph. That's going to be a tough graph for you to do, but try it. Here's the deal, though. Your graph by hand is not going to look this good. It's not going to look that good, but it should be a rough pre-calculus sketch. For example, you should be able to determine that this thing is always positive. It has a y-intercept. It's asymptotic, yada, 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 and also symmetric. It's folding symmetry about the y-axis. All right, you'll be able to do that. Again, all that stuff is written down for you. And again, if you need help, please, I want to encourage you to come by during office hours, and we can help you out with that. Okay, thank you.